Have you ever wondered how the world would look without semiconductors? The absence of these tiny components would mean no smartphones, no computers, no digital watches, no flat-screen TVs, an unimaginable reality in today's digital age. But what are semiconductors? And why do they play such a vital role in our everyday lives? In the next 7 minutes, we will delve into the fascinating world of semiconductors. Semiconductors are substances that have a conductivity level somewhere between that of insulators, which do not conduct electricity, and conductors, which conduct electricity very well. The unique properties of semiconductors come from the special position they occupy in the periodic table. Silicon and germanium, the most common semiconductors, sit right in the middle of the table, inheriting characteristics of both metals and non-metals. The magic of semiconductors lies in their ability to control the flow of electricity. They can switch and amplify electronic signals, which is crucial in devices like smartphones and computers. But how do they do this? It all comes down to a property called band gap. In semiconductors, the band gap is the energy difference between the highest occupied energy band, known as the valence band, and the lowest unoccupied energy band, called the conduction band. When the semiconductor is at absolute zero temperature, the electrons fill the valence band but do not have enough energy to jump into the conduction band. However, when we heat the semiconductor or expose it to light, the electrons gain enough energy to jump the band gap and move into the conduction band. This movement of electrons allows the semiconductor to conduct electricity. But the true power of semiconductors is unleashed when we introduce impurities into them, a process known as doping. There are two types of doping: N-type, where we add pentavalent impurities like phosphorus or arsenic, and P-type, where we add trivalent impurities like boron or gallium. The N-type doping creates an excess of free electrons, while the P-type doping creates an excess of holes. The interaction between these electrons and holes is what makes semiconductors so versatile. These doped semiconductors form the building blocks of semiconductor devices like diodes and transistors. Diodes, the simplest semiconductor device, allow current to flow in one direction only. Transistors, on the other hand, can amplify and switch electronic signals, making them the fundamental component of all digital circuits. So, what have we learned today? We've unraveled the mystery of semiconductors, substances that sit right in the middle of the periodic table and can control the flow of electricity. We've discovered that the key to their magic is the band gap, a property that allows them to conduct electricity when heated or exposed to light. We've learned about doping, a process of adding impurities that gives semiconductors their versatility. Finally, we've explored how these semiconductors are used to build devices like diodes and transistors that power our digital world. In a world that's becoming increasingly digital, understanding semiconductors is no longer an option. It's a necessity. So the next time you use your smartphone or computer, remember the tiny semiconductors that make it all possible.